Now looking at average and marginal cost, we're getting to some of the most important cost curves when it comes to firm decision making. So total costs, variable costs, fixed costs are all important as we're conceiving of the firm behavior overall. But when it comes to specific decisions that the firm makes, we're really going to be focusing in on average costs and marginal costs. So average cost is going to be just the firm's total cost divided by output. Right, so whoops, let's go back to our slide. That'll be total cost divided by output will equal average cost. This will be average total cost. Um, Average costs are going to primarily guide firms' entry and exit decisions, especially when we're focused on the perfectly competitive model. So we're looking at, for a firm, is participation in this market profitable or not, right? That's what average cost is going to show us. Marginal cost is going to have to do with how much the firm is producing. So marginal cost definitionally is the firm's cost of producing one more unit of output. And we're going to find it by taking the derivative, that's a D there, derivative of total cost with respect to output. That's going to show us marginal cost. So in essence, marginal cost is showing us how much firms' costs increase if they produce one more unit of a good. Right. So here on the slide, you can see these relationships, mathematical relationships more clearly. So average total cost, we divide total cost by output, right? So in essence, we're dividing fixed cost and variable cost by output, which means that we can break average total cost down into average fixed cost and average variable cost. So average fixed cost is just fixed cost divided by output, and average variable cost is just variable cost divided by output. That means that we can write the relationship between these three average costs as average total costs being equal to average fixed costs plus average variable costs. Right? If we take our average total cost relationship here, we have average total cost is equal to fixed costs plus variable costs, all divided by output. If we break that up, that fraction up, we'll get average total cost is equal to fixed costs over output plus variable costs over output. Fixed costs over output is just average fixed costs, and variable costs over output is just average variable costs. So we get, again, average total cost is equal to average fixed costs plus average variable costs, which is shown here in the fourth bullet. Lastly, marginal cost again is just the derivative of total output with respect to, the derivative of total cost with respect to output. So we're looking at how does total cost change when output changes. And as we discussed in the last video, the only cost that changes with output is variable cost. So really marginal cost is going to depend only on a firm's variable costs. Okay, so in the short run, fixed costs will have no impact on marginal costs, meaning that fixed costs will have no impact on how much the firm decides to produce. Okay. So we're looking again here at the firm's output table. You're seeing in the leftmost column output from 0 to 12. In the second column, fixed cost is constant at 50. Variable costs you see is growing with output, as is total cost, but just by an increase of 50 units. And then the remaining columns have marginal cost, average fixed cost, average variable cost, and average total cost. I've left them blank for you here so you can practice solving for these values on your own. So we can do the first couple so I can show you how it's done, and then I invite you to practice on your own time. The next slide will have the answers so you can see what you should be getting. All right, so for marginal costs, that is showing us how much the firm's total costs go up when they produce an additional unit. So when the firm goes from producing 1 unit to 2 units, it's going from producing, it's going from total cost of 50 to 60. So that means the marginal cost of that first unit is 10. Right? When it goes from producing 1 unit to 2, its marginal costs go from 60 to 67.5. So the marginal cost of the second unit now is actually less than the first unit. Moving on to 3, right, when the firm goes from producing 2 to 3 units, their total costs go from 67.5 to 72.5. So that's a marginal cost of 5. We'll go ahead and finish this out actually. So moving from 3 to 4, that moves total cost from 72.5 to 75. So that is an increase of 2.5 in marginal cost terms. Moving from output of 4 to 5, the firm's total costs go from 75 to 80. And so now marginal cost is rising. So this will be a unique shape of marginal costs that we're going to talk about a lot, where we have marginal costs initially falling, they hit their lowest point, and then they increase with output. Okay, so there's sort of a U shape that it's adopting. Often in graphs, it's graphed more like the Nike swoosh symbol. That's sort of the standard way of representing marginal costs, but there's still that initial period of falling marginal costs until they start to increase again. Okay. Average fixed cost, that's going to be fixed costs divided by output. Right, so let's do the first few here. So initially output is 0, so that's why all these values are undefined for that row of 0. Moving to 1, 50 divided by 1 is 50. 50 divided by 2 is 25, and then so on. For average variable costs, it's variable cost divided by quantity by output. So now we'll look at our variable cost column, right? Any number divided by 0 is undefined, so that's why this first row has those dashes. So we move to when output is 1, look at the variable cost is 10. 10 divided by 1 is 10. Then we move to when output is 2. So we have 17.5 divided by 2 units. So if we calculate that, we're going to get 8.75 for average variable costs. Right, so you get the idea there. And then average total cost is just total cost divided by output. So we look at our total cost column. Again, anything divided by 0 is undefined, so that first row has those dashes for that reason. When we move to output of 1, we'll have 60 divided by 1. That gives us 60. Output of 2, total cost is 67.5. We divide that by 2, and we get 33.75. Okay, so I invite you to calculate these columns for average fixed cost, average variable cost, and average total cost. What you should see is that average fixed cost is falling over output, right? As more is produced, the fixed costs are spread across more units, right? Fixed cost doesn't change, so the more we produce, the smaller the average fixed cost. What you'll see with average variable cost and average total cost is similar to marginal cost in that they'll have a U shape. They'll fall, 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 fall until a certain point when they start to increase again. Okay, so if we go to the next slide, we'll see that. All right, so again, looking at marginal costs, we see that initially they fall from units 1 to 4, and then from 5 on, marginal cost is increasing. Average fixed cost we can see falls across output. So as output grows, average fixed cost falls. This is where economies of scale comes in, which we'll talk about in that video. For average variable cost, we have that U shape that I was discussing. So initially it falls with output until we reach that 5th unit where average variable cost is at its lowest until it starts increasing again. And then similarly for average total costs, we see average total cost falling, falling, falling until they reach their lowest point at output of 8 when they start rising again. Okay, so there's that U shape for marginal costs, average variable costs, and average total costs. Right. This pop-up is summarizing all of that for you. And here are the graphs. So you can see in green, we have average fixed costs here, and it's falling, falling, falling with output. So it's always decreasing, right? And it's going to do so asymptotically. Whereas average variable costs, we can see initially it falls a little bit until it starts creeping back up. And then for average total cost, because it's influenced by average fixed costs and average variable costs, average total cost is going to fall with average fixed costs until that point where average variable cost surpasses average fixed cost, and then it has a greater influence on average total cost, and that's when average total cost starts sloping back up. Okay, but it's this portion where average fixed cost dominates that we get economies of scale. So there, we'll go ahead and end the video. And we're going to pick up in the next one with more of a discussion of, oh, excuse me, we're not stopping. Sorry about that. I missed this. This is average total cost. So we're still going to talk about this slide in this video. So looking at average total cost in the short run and long run, we're going to start applying that capital assumption. So in the short run, capital is fixed. That means that costs are higher. That should be an O. Costs are higher than the long run. Okay, so what that translates to is that for our average total cost curves, they're always going to be above or equal to the long run average cost curve, never below. Okay. So we can see that in the next graph. So this graph, sometimes students see it and they're like, oh my gosh, that's so many curves, what's going on? And I invite you just to take a moment and walk through it with me. So the dark blue curve is our long run average total cost curve, and it's showing average total costs as output increases as when firms can adjust both capital and labor. And so as we talked about, our long run costs are always going to be less than our short run costs. And so that's why we see that this dark blue curve is encompassing all of the short run cost curves. For each of our short run average total cost curves, they're defined for, whoops, sorry about that. They're defined for a certain level of output. So you can see that our first curve here is the average total cost in the short run for the production of 10 engines, right? And it's this blue curve that I've drawn the 2 dots at the end of, okay? Then we have another one for output of 20 engines and a third for the output of 30. And you can see that at a certain point in the short run, costs start to rise very quickly because the firm's having to hire more and more and more labor because it can't adjust its capital. All right. And so what we'll see is that production moving from 10 engines to 20 in the short run is going to entail a lot more cost than movement in the long run between those two values. Slide. Let's go to the next slide here. I'm having trouble changing the slide for some reason. Let me try to stop sharing and then reshare. Next, all right, there you go. So next we're looking at marginal cost. So here's our graph. Remember that marginal cost is looking at how total cost changes with output, right? So in other words, how much does a producer's cost increase when they produce one more unit of a good? And we can see that slight U shape in our marginal cost curve here. So as quantity of shoes produced gradually increases from 1, we see marginal cost falling, right, until probably about like 4 when it starts rising again, right? And this is the marginal cost that was shown in the slide, in the table previously. So it should line up there. And one thing to keep in mind, right? Learn this, love it, live it. Fixed costs are not going to impact marginal costs. So they're just going to reflect how output is changing, how variable costs are changing with output in essence, right? And so that's what you should see here again, right? We see that slight U shape in our marginal cost values, and we see it tracking variable costs. Okay. Next, we want to start thinking about the relationship between average costs and marginal costs. So this is what this pop-up is now drawing our attention to. Marginal costs are following average variable costs. They both decrease from producing 1 pair of shoes to producing 4, right? And then once marginal cost exceeds average variable costs, right? So that's at point production of 6 pairs, right? Now between really production of 5 and 6 pairs. Now as marginal cost exceeds average variable cost, both are increasing, right? So that's why we get the minimum of average variable cost at 5 pairs of shoes. And then once marginal cost surpasses average variable cost, they both grow with output. Okay. Marginal cost curves, just like average total cost curves, average fixed cost curves, and average variable cost curves are going to be lower in the long run. And that's again because of our capital assumption. Capital and labor are both variable, and so it's going to be easier for a firm to minimize their costs. This is going to translate to flatter marginal cost curves than we see in the short run. And then last point here, the marginal cost curve, whether in the short run or the long run, will always intersect its relevant average total cost curve at its minimum point. So in the short run marginal cost curve will intersect the short run average total cost curve at its minimum. In the long run marginal cost curve will intersect the long run average total cost curve at its minimum. Okay, so we can see that here graphically, right? We've taken that relationship between average total cost in the short run and long run that you saw previously and added marginal cost curves to it. So the steep marginal cost curve lines here, I'm just drawing brackets around them, you can see are paired with specific levels of output. Whereas in the long run, we have a much flatter, this is our darker red curve. And that's, again, reflecting that when firms can adjust both inputs, both capital and labor, they're able to minimize more effectively, all right? And so our long run curve intersects the minimum of the long run marginal cost curve intersects the long run average total cost curve at its minimum point, and each of our short run marginal cost curves intersect the short run curves at their short run average total cost curves at their minimum points. That will be a useful relationship for solving for economies of scale, which you'll see in one of the practice problems that we do. All right. So this is a relationship I articulated earlier. We can talk about it again. So as long as marginal cost is below average total cost, producing another unit is going to reduce average total cost. It's going to pull down the total cost for the firm. Again, we're seeing those economies of scale. When marginal cost exceeds average total cost, producing another unit will increase it. So it's going to be pulling up those costs. And this is, again, why we get that U shape to the average total cost. And we're going to see the minimum of average total cost be where it equals marginal cost. Right, so here's what we see graphically. We have average total cost in blue, average variable cost in yellow, and marginal cost in red is intersecting both of those curves at their minimum point. And this table is to show you that again, right? Marginal cost should equal average variable cost and average total cost at their minimum points, right? So that's where we should see the turn. So for marginal cost, it becomes equal with average variable costs between the 5th and 6th pair of shoes, right? So that's the point where we see average variable costs start to increase. And then for average total costs, we see marginal cost and average total costs equal, let's see. It's going to be between the 8th and 9th pair of shoes. At some point in there, they equal, marginal cost surpasses average total cost, and that's where we see average total costs again begin to rise. Okay. So this pop out is again just drawing our attention to that relationship. All right, so now we get to really what we want to try to answer. So we have all of our foundation for firms' decision making. So our next video is going to talk about how firms decide when to shut down. And we'll leave the answering the question, our first two questions to chapter 8, where we'll look at the perfectly competitive model.